That's me on a screen in the University of Heidelberg during the semifinals of Heidelberg Integration B 2026. Integration Bs. The idea is simple. Two people get an integral, faster to solve wins. MIT Integration B is the most famous one, but people host it on other universities too. A few months ago, I was asked by the Heidelberg Integration B team to submit a problem. Heidelberg, of course, an amazing university in Germany, one of the oldest in the world. I had to send a problem and a video introducing myself. And I have to talk about the video because I had this amazing idea to record my introduction in German to show my gratitude. The problem is I don't know German at all. Dozens of YouTube tutorials and days of practice later, now I can kinda read the script that my friend wrote for me. Anyway, here's my introduction video playing at Heidelberg.
Ich würde sagen, Video ab.
Hello Heidelberg. I am Zai.
Ich bin ein Mathe-YouTuber aus Korea. Vielen Dank für die großartige Chance, am Heidelberg Integration B teilnehmen zu dürfen. Aus Dankbarkeit habe ich mich entschieden, dieses Video auf Deutsch aufzunehmen mit Hilfe von Wörterbüchern und meinen Freunden. Da ich jedoch absolut kein Deutsch spreche, war diese Aufgabe eine echte Herausforderung für mich. Ich musste jedes einzelne Wort mehr als 3-mal wieder neu aufnehmen. Doch dann hatte ich plötzlich eine Idee. Ich sollte diese Erfahrung in eine Matheaufgabe verwandeln. Zuerst mag Ihnen dieses Problem vielleicht etwas fremd vorkommen. Genau wie ich dieses Video wieder und wieder aufnehme, werden auch Sie über diese Aufgabe mehrmals grübeln müssen. Doch so wie ich mit jedem Versuch mehr Silben auf einmal geschaffen habe, werden Sie beim Lösen eine ganz ähnliche Erfahrung machen. Good luck and think fast!
So as you've seen, the theme of the problem is about repeating something and getting better at it. Okay, here is the actual problem. If you want, you can pause and try right now. The time limit was 5 minutes in the actual contest. I'll show the answer in 3, 2, 1. The answer is -9 pi over 8. And here is the solution. Okay, as I solve, I'll also talk about my intentions and how I thought a contestant would solve this problem. What I wanted to test with this problem are pattern recognition and a little bit of integral knowledge. Okay, let's see the problem. The first thing is, what the heck is this, right? This much is what we need to integrate, but there's this thing on the sigma. So even before we get into this part, we are kind of blocked out by this. This is the ceiling function. If the value in it is between 0 and 1, then the ceiling would be 1. If it's between 1 and 2, the ceiling would be 2, and so on. Since we have x over pi, if x is between 0 and pi, then x over pi would be between 0 and 1. So the ceiling would be 1, and so on. If we draw it as a graph, it looks something like this. If x is from 0 to pi, then the ceiling is 1. If it's from pi to 2 pi, the ceiling is 2. 2 pi to 3 pi, it's 3. 3 pi to 4 pi, it's 4. Let's see now. We integrate from 0 to 4 pi. If we divide that into 0 to pi, pi to 2 pi, and so on, then in each interval, this expression will just become a number. If you had that thought, then you may divide this into 4 intervals like this. From 0 to pi, the top number is 1. From pi to 2 pi, it's 2. From 2 pi to 3 pi, it's 3. From 3 pi to 4 pi, it's 4. Dividing like this solves the first step. When I made this, my hope was that the contestants would reach this part in 1 minute. Oh, and by the way, here's where the theme of the problem comes into play. That story about me recording in German, the more I repeat, the more syllables I could say at once. You can see that these integrals repeat over and over, but the length of the sum inside increases 1 by 1. That's how the theme is represented. Now, it's possible to write out all the terms inside these sums, but the time limit is 5 minutes, so writing it all out takes too much time. This one contains the n equals 1 case. This one contains n equals 1 plus n equals 2 case. This one contains n equals 1, n equals 2, n equals 3. And this one has n equals 1, 2, n equals 4. Look, the n equals 1 case exists here, 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 and here. If we just take out all of that, then we can combine that into a single integral of the n equals 1 case. Same for n equals 2, it's here, here, and here, so we combine that into a single integral. If we rearrange the integrals in this fashion, We get n equals 1 from 0 to 4 pi, n equals 2 from pi to 4 pi, n equals 3 from 2 pi to 4 pi because it's here and here, that's from 2 pi to 4 pi. And then n equals 4, that's only here, so we get 3 pi to 4 pi. Rearranging like this could save you a lot of time. Now let's actually properly write these integrals. Here's how it looks like. If n is 1, then you just get this. If n is 2, then I squared is minus 1, so you get this. If n is 3, then I cubed is minus I, so that's what you get. If n is 4, then I to the 4 is just 1. I think you have to get to this point within 2 or 3 minutes to solve the problem. Now we have to calculate this, and there is a reason I put I here. It was to guide the solver to think about the sine and sine cubed terms separately. The graph of sine x goes up and down like this. Integrating this from 0 to 4 pi means you have to add these two areas and subtract these two areas. But the ups and downs have exactly the same area, so this thing just cancels out and becomes 0. Same with sine x cubed. From 2 pi to 4 pi, you need to add this part, subtract this part, and that cancels out and becomes 0. These terms with imaginary numbers just goes out first and it becomes clean. You can just erase them with the shapes of their graphs. We're left with 2 terms, and now we actually have to calculate. Solving this will solve the problem. In this part, I honestly think the contestants would probably already know how to solve these 2 expressions. So my hope is that this part wouldn't take more than 2 minutes for them. These were also in the guide document made by the Heidelberg integration team as example questions, and I think some contestants may have already memorized the solutions. Sine x squared and sine x to the 4 are functions with a period of pi. So integrating from pi to 4 pi is the same as from 0 to pi times 3. Minus 3 times that plus this, and the value of this is pi over 2, and the value of this is 3 pi over 8. So just minus 3 pi over 2 plus 3 pi over 8 is equal to minus 9 pi over 8, and that's the answer. And let's say you didn't memorize the exact values of these expressions. In that case, here's one solution that works well here. You rearrange the integral again, pi to 3 pi and 3 pi to 4 pi. Just split this thing like that and that. Now we have this part, which is just half of 1 minus cosine of 2x, and that can be solved. And here we did this because we can take the sine squared out, and we are left with sine squared minus 1. And that is minus cosine squared. So it becomes minus sine squared cosine squared. And let's rephrase that like so. Then we also know that sine times cosine is half of sine 2x. So we get another sine something squared. Using that formula again from before, we now have minus 1/8 of 1 minus cosine 4x. I went over this really quickly, but if you are interested, you can try it out yourself too. Anyway, if you do all that, this part becomes minus pi, and this part becomes minus pi over 8. So the answer is minus 9 pi over 8. So that was my intended solution, but how did the contestants actually solve it? This was the first problem of the semifinals between Felix and Benedict. To the right, Benedict was the first to realize that you can split the integral into 4 parts and rearrange them. He didn't even need to write all the terms, so he did it really fast, in just over a minute. Felix also realized that you can split the integral, but didn't actually write it out and had a little bit of trouble finding the breakthrough. Meanwhile, Benedict made a guess. Now, in this format, you can only make a guess once per round. Unfortunately, Benedict misremembered the values of the second and fourth terms that now he realizes the mistake. So now it's up to Felix to solve the problem in the remaining time, but he spent a bit too much time on rearranging the integrals and didn't have enough time. I think if he had just like 30 more seconds, he would have got it correct. So yeah, really close for both sides, but unfortunately, my problem at the Heidelberg Integration B resulted in a draw. Nevertheless, it was like really cool to see these people try out my problem in an event like this. Like, I couldn't believe something like this would happen. Integration Bs are so great. I hope universities in Korea host Integration Bs too. Yep, thanks. Bye.